Sure. Testing, 1, 2, 3. Everybody, can you hear me loud and clear? Welcome. Give me a 1 in the chat if you can hear me. Welcome to another, once again, Building Stuff with Nova. I'm super happy. Today we got a very technical episode, but let me give my pleasantries out of the way. This is the place for those who are joining us on YouTube, or if you are joining us on Twitch, our normal home. This is the place that we like to refer to as our virtual makerspace, and you're going to see why in a little bit. Our ideation laboratory, your mastermind, if you will. I am your host, Dr. Nehemiah Mabry, and I like to consider myself your companion. I'm like your partner. We hang out. Sometimes I cover the bill. Sometimes you pay for it, and I forgot my wallet. But at the end of the day, we're just building together. You and I are friends. So I'm super happy to have you all with me. I'm glad you can hear me, Nova. I want to know who's with us on YouTube. If you're with us on YouTube, joining us from a certain place, geographical location, go ahead and drop that in the chat. I see Becky Stern, who we're going to bring on in just a little bit. Lunatic, we see you. Thumbs up, thumbs up. That Opal guy, our old friend. Shout out to, again, Becca. We see you over on Twitch. If you are on Twitch, drop something in the chat. Give me an exclamation point even. If you just want to let us know that you're here by dropping an exclamation point. We love the vibes. We love the energy. And we're going to get down and dirty, if you will. Maybe not dirty, but we're going to get busy today with our hands. In just a little bit, I'm going to go ahead and pull up our agenda. Let's pull up our agenda for today. We have a special guest that I'm going to be introducing to you, Vic. Shout out to Vic, come to us from India on YouTube. Becky Stern is going to be joining us here in just a little bit. And we're going to be creating a custom LED layout. Now, I have a couple of parts here, right? I have some stuff that our good guest today has sent my way, and I'm going to switch to my overhead cam a little bit, and you can get a better view of this. But I want you all to stay tuned because this is a technical one, and if we get a little technically complex here and there, just bear with us. As a matter of fact, if you missed yesterday, you missed a treat because we did some hardcore coding. We did some training of an algorithm to make sure that it can identify images, whether it been a dog or a cat with Meta Dev Girl yesterday. If you didn't see that, go back and check that VOD out. And one more thing I got to tell you to do before we bring our guest on is that you have to apply for this great opportunity. So shout out to Nova. If you can drop the link in the chat, we are advertising an application that will allow you, those of you who are part of our building community, anybody who's been around for more than 2 seconds, to apply to be a part of our finale. Our finale is going to be a 4-part engineering escape room. That's right. If you've hung around for a couple of weeks now, you've been a part of the ideation process where we had Tripology Boston on a stream on a weekly basis, coming up with ideas, integrating a lot of different engineering concepts into an escape room puzzle series. And now they are currently building it. We have another virtual tour coming up next week where you're going to see their progress. But the link in the chat right now, I see the link dropped on Twitch, the link on YouTube, maybe the link, I'm not sure. We're going to get a link on YouTube as well. But let's get the link on the screen. You see it on the screen right now. For all those who are interested in being a participant, a player in our Building Stuff escape room, this is going to take place at the end of October. You have an opportunity to fly to Boston. I like to say fly up because I'm here in North Carolina. You can come east, west, wherever you're coming from, or down south relative to where you are. But if you are selected, you will be a player who is able to participate in our 4-part engineering escape game. Now, I don't know about y'all, but that sounds like it's pretty dope. I see herself says dinner on knee. I don't know about all that. Like that's not quite in the fine print. So I'm not going to get myself liable on dinner, but I'll get to see you in person. I get to give you a nice handshake, a nice Building Stuff welcome and love to say that, hey, it's great to see you in the flesh, but you have to apply to even have a shot. So there it is right there in the chat. Make sure you click on it if you are interested. There's also the link on YouTube now. Adam, hi, Adam. Get to see you, Adam. Lena, get to see you, Lena. Nina, yes, that link is what you all want to check out to be able to apply to be a participant in our grand finale. And that will be the engineering escape room right here on Building Stuff in about a month and some change. So go ahead and apply. By the way, let me say this too. I found out today that the deadline was extended for the application to September 27th. Nova, can you confirm that in the chat? We have extended the deadline for the applicants to September 27th. So you got a little more time. We've already gotten a few applicants, but we're waiting on yours. Yes, we're waiting on yours. So go ahead and get it in there. We want to at least see who we want to bring in and participate with our team for our finale. Sounds cool? If that sounds cool, let me see some hearts. Let me see some emotes. Let's get some energy, some vibes. Drop it in the chat because I want to know that you all are with me. And I'm about to bring on the screen at least an intro slide of who else is going to be with me today. And that is none other than our guest, Becky Stern. So check this out. Here we are today, building stuff, building committee. I want to introduce you all to our guest today that goes by the name of Becky Stern, at Becky Stern. Now, she has authored hundreds, not dozens, but hundreds of DIY tutorials about everything from microcontrollers to knitting. She is an independent content creator and STEM influencer living in New York City. And now, before she did YouTube, and by the way, you can see her, if you just type in her name on YouTube, you'll see some videos that she's done. But before YouTube, she worked as a product manager at Instructables, which is owned by Autodesk, director of wearable electronics at Adafruit and senior video producer for Make Magazine. Now, what we have today, I want you all to understand, we have another person that occupies this rare sort of like, we have another person today that occupies this rare like intermediate area. Sorry about the video thing. We have this intermediate area of content creation and technical intelligence. Someone who blends content and creative genius with technical intelligence. That's who we have today. So I need you all to get the love, get the energy going. Let's get some hand claps. Let's bring some more energy to the chat as we present to some and introduce to others. None other than our guest today, Miss Becky Stern. Becky, how are you?
Hello, thanks for having me. So happy to be here.
Absolutely, absolutely. Happy to have you here. We've been working out now. We've already had just a little technical thing, but listen, this stream is about to get very technical, is it not? Like, because we have another technical creative with us.
For sure. Here we go. Get ready. Strap in.
Strap in. And let me just go ahead and get back to, and before I even ask you, like some of the typical interview questions, I'm going to weave that into our time because I want to get busy right away because you have sent some things my way. You sent some things my way that are going to really be instrumental, if you will, in our stream for today. So let me go to another overhead layout really quick. Now that we have our New Yorker in the building. All right. I have right here overhead. Sorry about that. Getting a little glitchy over here. All right, here we go. Let's see. We are. Becky, could you share your screen again?
Yeah.
All right,
there it is.
Yep. I think we. Okay, the screen jumped around. All right, so we're gonna have to do a few things today, chat. So get ready, strap in, posse. We get to see you. We're gonna be switching some wires up. This is engineering in the making. Steph, Adam over on YouTube, Ziv. We're about to do a couple of things. I got Becky right here with me. Let me make sure you are back up to where you belong. Okay, there you are, Becky. You're with us. And I have an overhead cam that I'm gonna get going here in just a second. All right, the overhead cam has, boom, it has you, it has me, and it has us.
All right.
Okay,
we're ready to go
there
then.
we are.
Right?
I have you, and I'm going to bring you in here in a little bit because I want to make sure that everybody can see what we have going on my desk here. All right, so here's this. We have your screen share, and I'm going to switch it in a little bit, y'all. But right here on my little area, right, we have my overhead cam showing me. There we are. It have me, you on the bottom. Can you all see my overhead cam? Can you all see that? Everybody, let me know in the chat if you can see that. Shout out to Nova, keeping the energy going. Can you all see the overhead cam? Becky, you see it?
I mean, I don't see it on the stream yet. I see it on Zoom. I don't know how far behind I am.
Oh, no, you're good. You're good. You're on. I have a few things with me, Becky. First of all, I have some nice Becky Stern stickers that are going to find some homes on some of my electronics. You sent this here, too.
Now I can see your overhead on the stream, yeah. I sent you an Arduino Uno board. So that's like the flagship Arduino board. It's a microcontroller platform that's
Uh-huh.
open source, so people can build their own electronics ideas using this microcontroller. And one of the things you can do with it is power a whole bunch of LEDs. I know you like LEDs because you
Yes.
have those cool LED pole things behind
Mhm.
you, and I want to like demystify how those animations are working. And we each have like the same circuit, and we'll work on some code to make some LED animations.
But Becky, it came like this. And are these two separate things? The Arduino is this.
That's just the box. And I just wanted you to have the retail packaging because I
Oh,
think
okay,
Arduino is
yeah, the
a
nice.
good company that makes good hardware, and I wanted you to be able to show the actual nice packaging that they have for their
Boom. So
product.
you gave me a nice hand model opportunity there with the box. And so
It's just the
now,
box. Yeah, it's just the box. I didn't want to deny you.
okay, cool, cool. So right here, and I'm gonna make sure my focus is good. This is the actual Arduino. What are the components that are already hooked up here for me?
So I have soldered on a set of wires to your pixel strip there. Um, and if we're sharing my screen, I can show you a
Okay,
close
I
up of
gotta
what
go
that
to your
looks like.
screen too.
Um, I see it on so it's on the left
So
side.
here's your screen. You got code and some images up there. There it is. Okay.
Yeah, so on the left, you can see the pixel strip in my hand. That's the same as the one in your hand, except you have like the silicone casing on top of it. That's what that outer shell is. And
Okay.
I've just attached 3 wires to the pixel strip for you and then plugged them into Arduino. One of them is power, one of them is ground, and the other one is for the data. This particular type of LED is got a 1-wire data protocol, so it's really easy to hook up like so many LEDs using just 3 pins on the microcontroller, only one data pin. So that's a pretty cool upgrade. It's because these LEDs have like a little chip inside them
Yeah.
that makes them addressable. They're not just plain LEDs. Otherwise, you would need like a ton more uh pins, like 1 pin per LED, but I'm able to just use 1 pin for all the LEDs. And so
Okay. And then
yeah, you can see here in the this like macro shot, you can see the different LEDs inside this one package. It's like a cool chip plus LED package.
also these LEDs. That's a close up look of what's inside of this LED thing.
Yeah.
Okay, got it. And now before in chat, by the way, we're gonna continue to get a little bit messy here. Now, before we talk, you said I needed one more thing before we get going. I need to be able to power up my LEDs before we get going, or what do we need?
Yeah, you need a USB cable to
Right
plug
here,
in the
right?
Arduino board, which happens to be a USB-B.
All right, so here's the USB-B. I'm about to make a quick change really quick. Becky, let me ask you this, and it may change my audio a little bit. Chat, just a heads up, my audio might shift a little bit because again, this is what engineering is all about: iteration, trying.
Because we're going to own up to the fact that Dr. D only owns one USB-B cable.
I mean, come on, like when you put it like that, I mean, when you put it like that, I guess yeah, I have one.
I could have just
to
said,
switch it.
I mean, for the record, right? Like I could have
Yeah.
sent you one. You told me you had. So
Yes,
I think that
this was not on Becky. This is totally on Dr. Nee. But for you all, chat, we're still gonna keep it moving. Becky, can you please answer this question though, as I make this switch? How did you even get into this? Give us a little bit background of how you even got this awesome career at the intersection of content creation and just really tech.
Yeah, art and technology. Well, I did go to an art and technology undergraduate program. That's like I'm an overeducated East Coaster, typical. Like, I found this cool program at Parsons School of Design called Design and Technology, and that's where I got into electronics. I didn't go to engineering school, but I did go to like fancy liberal arts college for undergrad, and that got me exposed to like, oh, I can just play and take whatever classes interest me, and I was taking a lot of art and like silkscreen and stuff, but also programming like video games was a lot of the like people in the program were doing, and I really preferred making code that like interacts with the physical world, and so that's how I got into electronics. I went to graduate school in Arizona State, where I dropped out twice, once of a PhD and once from an MFA.
Oh wow.
And I started making content while I was in like late undergrad or grad school. So I don't know, I get like a high or like a dopamine rush from like publishing useful, fun content. So I've been making videos since like 2008. The old ones are really crazy. Like
I saw some of them. I saw some of the old videos, by the way. I did my research.
And I found my niche, I guess, in Arduino programming. Arduino like hit the scene in 2005 when I was like in college, so it was like the perfect it's a platform that's designed for artists and designers. So I was like the perfect target demographic, and that, like, because I kept using it and publishing content, like I became like one of the foremost, people making Arduino, free Arduino content online. Now there's like, you can find a bunch of Arduino classes, but I would like to maintain that mine is the best free Arduino class on the internet, and you can find it on my website and on the Instructables website. And I teach part-time at a school here in New York called School of Visual Arts in the Products of Design graduate program, where I teach exactly this. We're going to do an LED Halloween costume for their midterm projects, where they'll like wear a bunch of LED strip and we'll walk in the New York City Halloween parade. So I've always been involved in a little bit of academia. I think there's like 1 year that I didn't teach or be in school. So I'm very like school affiliated all the time. But I had that full-time job at Make after I dropped out of grad school. Then I worked at Adafruit and built out their whole wearables and YouTube sort of presence. And then worked at Instructables making content first, like publishing this Arduino class that is it's evergreen mostly. We need to update some of the screenshots, but I got fun being like a central person in the DIY community. I take responsibility for paying attention to what's going on and being an active community member there. So that's how I got here. I went to school, and I love sharing online and connecting with people online. So I care a lot about publishing things that allow people to like teach themselves.
Now I'm gonna circle back to that, by the way, Becky, because you do a lot of things actively that people watching can take advantage of. The whole DIY, one of the leaders in the DIY community. But first, let me make sure everybody can see, because I finally disconnected the cord. The microphone is coming from a different location. Am I too loud? How do I sound, everybody? Everyone sees? Can everyone hear me well? You all can hear me good?
You sound okay to me.
Okay, cool. So check this out. I'm about to switch my overhead back to my overhead and plug this in so they can see the nice little program light show that you already uploaded on the Arduino. Look at that. Chat, you all see this? This is
sample code.
So Becky, did you program this? Did you program this?
It's just it's the sample code. I did like hit the upload button to put the sample code on the board.
Okay.
It's the sample code that comes with the NeoPixel library.
Got it.
It's the code that's on the screen right now too, and we're going to talk about it.
Okay, so the code that y'all just saw from Becky's right here that Becky's showing is what's doing this light show right now on my LED, which is pretty dope. And you said that you're gonna put. By the way, Becky, this is another follow-up really quick. You said that you're gonna design Halloween costumes for the New York City Halloween parade. Is this like kind of what you're gonna use, Arduino and LEDs?
Yeah, my students. Yeah.
Okay, got it. So how can I do the same thing? What are we gonna do now today? How can I hook this up myself?
So I wanted you to start with a starting point that was visually interesting. So I already plugged in your 3 wires and loaded this code onto your board. But if you wanted to go ahead and install the Arduino software, that's something that everybody can do for free. And you can also use their web interface. So I have my screen share now. I'm on the Arduino website. You go to the Arduino refers to like this company that makes this hardware, but also this free and open source software. So you can either download the integrated development environment here, but you can also log in to an account on the Arduino cloud, and you can use their web interface for programming. I think you have to install a plugin for the serial communication.
Which one do you recommend? Like, what is the free? What is like the best
I usually have my students install the desktop app, the IDE, where you download it on your own computer. But let's see, hang on. But that's just because I'm kind of old school, right? Like I did this stuff before there was an IDE, a web-based thing you could use.
Right,
so.
Meaning you always had it on your computer. Like that was normal.
Computer. But now I can't find it. Oh, here it is. Okay. So yeah, you can use the let's see. Here we go. Cloud editor. Here we go. And so either one of those is fine. I recommend you set up one or the other. That cloud setup, you have to make an account.
Wait, go back just a second ago so the audience can see it. I saw it, but we were on my overhead. So go to.
So I made an account on the Arduino Cloud website, and then I selected to create a new sketch. Or you can go to the software, the arduino.cc website, and you can go to the software tab and you can download the IDE for your operating system, Windows, Linux, and Mac.
Got it. So that's how you all can get involved in this on your end. All right, so I'm already I'm on. I have an account, and I want to create my own code. So
you ready to go?
So I click on this.
So you click on New Sketch.
New Sketch. That is, where is that at?
Upper right hand corner.
Boom. Okay.
Under Create New.
Create
I can't
new.
actually see your screen.
Yeah. I'm here. I'm here with you. I'm right here with you.
So you have it. So look at. Can you see my screen share?
Yeah, I'm following you. I have mine up. Chat. I have mine up. I'm going to do the same thing, but we're going to see. This won't really connect to my Arduino though, will it? It'll automatically go to my Arduino.
Well, yeah, it will.
Okay.
Yeah.
Nice. All right, cool. So let's.
The Arduino board has a little serial communications chip on it, but communicates over USB to your computer. So you have a new sketch here. Want to do some stuff? It's over.
So these are libraries, and we did some coding yesterday, so we were familiar with some of the terminology. So NeoPixel is what I need to search. Okay. 804.
You see it on the left menu of the when you expand the examples for the NeoPixel library.
Mm-hmm.
So I'm selecting strand test as the example. It's going to open up a new tab with that sketch open.
Wait, so you went really fast just now. I didn't see what you clicked on.
Yeah, it happens really fast. So here you have the NeoPixel library open in your left menu.
And then I click on examples.
Expand the examples, and then click on strand test, and it'll open that new example.
Ah, okay. Strand test, I got to open.
Yeah?
Yep, I got what you got.
Okay, cool. So then this is the sketch. It's the same sketch that I have in my Arduino IDE on my computer here, which I have the dark mode one is the software running on my computer, and the light one in the browser is running in the browser, but they're both the same. They're both the same. You can program your Arduino either way. So is that good? Do you want any questions about that? Installing the software?
How would I have gotten this? So this is what you have on your board. This is not what I have right here playing on my screen though, right? This is not the same thing. This
sample code is what's running on your board, yeah. And I want to talk you through it when you're ready.
Okay. Chat, any questions real quick? We want to make sure that everybody's coming along. And by the way, somebody asked this question. This is really bad. And your audio is maybe a little in and out too, FYI. But here's the question, Becky.
Right.
What's sort of the best Halloween costume you ever designed? This came early when we were talking about Halloween costumes.
Last year, I did a spaceship out of cardboard. There's a video on the DigiKey channel of it. It's like a low poly spray painted silver cardboard UFO costume that's studded with LEDs around the outside, and you wear it kind of like a pair of suspenders. And then I could be like an alien, and I could carry a camera and be an alien tourist. That's what I did last year. My students, though, have done some really creative things too, like butterfly wings. Like, had a crew of fairies one year, or a crew of Star Wars characters with lightsabers. There's you can totally do some prop replica stuff with these LEDs, or you could create your own design. So, yeah,
there are a lot of different things you can do.
Less.
Good question herself. All right, so I'm gonna try to keep this light display next to me just in case we need to see both. But now I think I'm ready to start coding.
You ready to talk about the code? Okay.
Yeah, let's do it.
So I wanted to highlight that. I wanted to be able to show you you can see my screen online right now. Yes, okay. You can see how the LEDs are connected to the Arduino board here, and there's a label on each of these pins, right? So like the power wire has a label, the ground wire has a label, and the data wire has a label.
Okay.
And in the picture and on the circuit in your hand, the data wire is going into pin number 6.
Yes.
And in the code, you'll see that like the first thing that you define on line 20 is which pin is connected to the LEDs, and we're setting that to a number 6.
That's where it says LED underscore pin 6. Got it.
Yeah, so that's going to be how the program that's going to run on the chip on the Arduino, it's going to say on pin number 6, you have some NeoPixels connected, because just by plugging it in by itself, it's not going to know. The program has to know about it.
Okay, got it.
So yours is plugged into pin 6, and then the next thing we define is how many pixels there are, and like you have, I don't remember, like 180 or something. And you have like a broken strip I had laying around, and I have like a complete one. It's like 300 long.
Are you telling me you gave me your broken parts, Becky? That was just saying, you're like, hey,
yeah,
newbie.
It like came apart and became shorter, and I used what was left over to create yours. And the only difference is that more LEDs than me, right?
I'm a newbie though.
We recycle all the time. Yeah, there's a project on my YouTube channel that used these LED strips, and like, you think I'm just gonna throw them away?
Of course not. You're gonna give it to the newbie. The rookie.
They work perfectly well. I just mean that your strand is a little shorter than mine. That's all. So got the LED count here in the sample program. Like we didn't need to change the LED pin, but we do need to change the LED count. So mine is 300, and yours, I can't remember how many yours is, but you can set it to.
Is it the numbers?
It's like. No, you have to count. It's like you would have to count them. We can figure it out just by estimating here. Like I would put in 180 for yours to start, and we'll see if all of the LEDs don't light up, then we'll add more.
That works. I'll go 180. Sounds about right.
Yeah. So your LED count, like set it to 180, and I've set mine to 300.
Okay.
And because that's how many LEDs are in my strip.
And by the way, Becky, can you maximize your screen too? I want to make sure everybody can see as much as possible on the screen.
Maximize my screen. What is the effect you want? My text to be bigger?
Yeah, just a little bit if possible, because we see a big white strip above your window.
Oh, right. Like you want to do like this.
Yeah. Or just want to use more space.
Okay.
If possible.
It makes it so I can't see you anymore, but that's okay.
Oh no. You don't have to do that. You don't have to go over to the side. Just maybe like you just did.
Here, how about here? That's good.
Yeah, that's good. And then can you make that
also
text
like
a little bigger?
Make it a little bigger.
Boom. There we go. All right. Can y'all see that chat? Everybody's good. All right. Cool.
Yeah, it's big. Okay.
All right. So
I wanted to go over a few things that I think we skipped over, and that's like Arduino code is this like computer language. It's that you're writing that is like in between what the microcontroller understands and what we can write as humans, and so it actually gets compiled into a machine code and down to an assembly code and then put on the board. So this is like this like interface we're looking at is kind of like how we write the instructions we want to control the LEDs in a way that the microcontroller can understand. And everything that's here in the colored lines is all the code, but everything that's here in the gray with the slashes in front of it is just a comment. And so it can look overwhelming. Oh my gosh, what is all the text?
Right.
This text is just a big comment so that the humans who are reading it and writing it can understand what's going on. And because this is a library sample code, it comes with really great documentation. And that's one of the things I love about the Arduino community is that like to get started with something new, all you need to do is like click over to it and then read what's going on, right? So this is just some like tips and tricks. Like if you're use a capacitor, it's optional. Use like manage your wire length, blah 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 blah. But these are just comments, and if you're wondering what's going on in the code, you can read it. So I explained to you that this is the pin that the NeoPixels are connected to. But if you didn't know that, and I wasn't here to explain it to you, there it is in a comment. So always read the comment.
What language is this, by the way? What language?
This is the Arduino language, which is based on C++. So it's like C++ with a bunch of built-in microcontroller friendly functions.
Got it. Okay.
So you can write, I don't do it very often, but you can like write a whole class, but I usually just leave it into plain C where it's just like you have your global variables, you get your local variables, all your lines ended semicolons, all that comforting things about the C language.
All the comforting things. I love it. I'm going to throw this around.
Yeah, it's not white space delimited, like no hate on Python, but like a little bit of hate on Python because space delimited languages I think are a little bit harder to learn.
Gotcha.
All right, so while I was talking, I just copied my file because it kept giving me a warning that you can't modify the examples, and I want to like save this as my own, basically like save as. So I just went ahead and.
Wait, do I need to do that? Because I'm like following along with you.
Yeah. So up at the top of the screen, when you click on the thing that says the sketch name, which is strand test, you can like save it to your copy it to your own, and then it'll stop being the sample code, and it'll be like a copy of it in your own. So at the top, click on the strand test text next to the word sketches, or sorry, next to the word example.
Yep.
And then click the button to copy it or share it or rename it to your own, and then give it a.
So mine just says examples, and it says save in your sketches, download, or share.
Save in your sketches, yeah, that's it.
Boom. Got it.
That makes it so now the edits that we make will stay.
By the way, if you're just joining us, y'all, this is Building Stuff with NOVA. I have a good friend by the name of Becky Stern, who is a little bit shifted on our screen right now, but we're going to bring her back together. And it's showing her monitor where she is doing some code. Right? And her code is in Arduino. It's for Arduino. Right, Becky? And we're about to modify the LEDs that are around my neck right now.
Exactly. I should wear mine as I can wear mine as a hat.
There we go.
We have fixed LED strips, and we're learning how to code them. So we're breaking down the program that is in the that's the sample program that's running on both of our LED strips, and we're going to learn how to customize it to make something, I don't know, like those LED poles behind you that have like a chasing pink only, right?
Right here. Yeah.
Okay. Yeah, like those. We're demystifying that. So we've already introduced some basics of Arduino, like opening up a sketch using their Arduino.cc cloud editor. And we've opened up the NeoPixel example, and we've talked about what a code comment is. And we're going down the line and figuring out what this sketch does. So far, we've gotten as far as making sure the Arduino knows what pin the LEDs are connected to and how many there are. And the next thing we're going to do is instantiate one of the NeoPixel class. So in the library that we have, like under the hood, the library code hosts has some conventions in it, and all you need to do is create the object here, the Adafruit NeoPixel object, and it'll have all of these arguments that you pass to it, and the comment here explains what the arguments are. Did you talk about arguments yesterday on your?
We didn't talk about arguments, but we have
arguments are things that you pass to the software. Like it's like the pieces of information that the software needs to know what you're doing. And in this case, you're saying like create a strip of NeoPixels, line 26 I'm looking at here, create a strip of NeoPixels that has the first argument is how many, and we've already set that in our LED count variable on 23, our defined statement. Yep. Then the next argument that it expects is the number of pins. Then the next one is the configuration, and the last one is the data rate. So in the sample, like this line is going to create like an object that will control the pixels that takes into account the two factors that we just put in, the LED, the number of LEDs, and the pin that they're connected to. My pin is 3, by the way. Don't change that. Yours is 6.
Mine is 6. Okay, yeah. And
okay. So that's like all the stuff in the beginning. Like that's not even really part of the program that runs all the time. This is just like the pre-code configuration.
Right.
And then the next element of an Arduino program is this setup function that runs once at the beginning of the program. And then the rest of it is inside this this loop function that will run over and over again. So there is like a little bootloader code that runs on the microcontroller all the time that hosts this sketch basically, and will say, okay, I know what this setup is and I know what this loop is. And that's like part of what Arduino has built on top of C, is that like Arduino implies that you're going to have both of these, a setup and a loop in every single program. And the setup is stuff that runs once. So in our case, setting up like a this is like only code that executes.
Was that like the first thing, like when I first plugged it in and the lights went all the way around? Is that a setup or no?
It's starting into the loop, but before the setup, there's the things the code just requires us to do a few things like initialize the strip object, and optionally we set the brightness. So because we're using so many LEDs and we're powering them through the USB port on our computer, we're only having them at like 1/5 brightness right now,
Right.
And they're still bright.
So this could be brighter. This could be brighter than
the mandatory thing. Like strip.begin is a mandatory code you have to put in the setup when you're using NeoPixels, and then the brightness is an optional thing. So like all throughout the whole program, we know that the brightness will always be at 1/5 brightness, basically.
Yeah. Somebody says in the chat, I've got a DIY nano leaf project in the home hobby backlog. Nano
Cool. Nano leaf is like a product that somebody made with addressable LEDs that like look really nice and mount onto your wall, and they're like a tileable like wall art thing. So like this coding exercise we're doing is definitely relevant to nano leaf stuff. I hope this gets the dust off of it and gets you working on it, because I know that those things are so pretty, and they're also really intimidating to start though. So like just start. Look what we're doing.
Just start. Clockwork. We see you. Just start.
Okay, so the loop is where all the magic happens. So everything that's happening with the LEDs around your neck and around mine is listed. It's happening procedurally in the highlighted section here inside the loop function of our code. And you can see that there's a little comment to describe what's happening. So that red that you see flash at the very beginning, it's using this function called color wipe. So a function is just like a collapsible bit of code that lives somewhere else and executes when you call it in like this. So I have to like find this color wipe function to see what it's doing, right? But the arguments that it takes are a color, which in this case is red, and like I'll tell you later about it being the speed. But like, do you know, like folks who know Photoshop know that color can be represented by an RGB value, right? We have red, green, and blue light, and when you combine them in different ratios, you can make any color of light. So if like Photoshop RGB values like correlate exactly to what we're doing here for like to define the color. So your color is defined as 3 numbers. One is the red value, one is the green value, and one is the blue value, and they're each on a scale from 0 to 255. So I know that's a lot, but let's go to the color wipe function and see what's happening. So like basically this line here, 57, is going to execute the color wipe function, and I need to go like find out like, oh, well, that's cool. What does that do? Here's the color wipe function down here, starting on line 78, and it iterates through a numbered list. That's what this for loop does. It says starting at 0, let's count up by 1 through the number of pixels. Strip.numpixels is a variable built into the NeoPixels that will be equal to the variable you set, the number of pixels you set at the beginning of the program. So it says like start with 0, keep going until we're at the end of the pixels, and increment by 1. That's what I++ means. And so in this loop, it'll say set the current position pixel to the color, then show it, then wait a bit, then do it again for every single pixel in the strip. So like this I number will iterate in this for loop. From the first time through the loop, it'll be 0, so it'll be pixel 0, and it'll make it red. Then it'll go up to pixel 1, pixel 2, pixel 3, and it'll make them red. And in the code up top, we have the color wipe function is called 3 times. Once and it's given red, once and it's given green, once and it's given blue. So that's why you're seeing like a big chain of red, then a big chain of green, then
and it's like I guess it's in order that you put it, right? Like you can switch those
sequential
orders.
Okay. Yeah, I mean there's a little bit of code folding going on, right? Because like this function is executed and it's outside, but yes, like we're seeing color wipe red, then color wipe green, and the color wipe function. So like if we want to play around with it and we want to like make it not red anymore, we can change these colors by adding making this RGB value whatever we want. We can play around with it, and like I'm gonna change the comment so that you understand that it's making my new color. And then I can also just temporarily comment out all of this other stuff.
And comment out means that you're basically making it so that it doesn't read it. You're just putting 2 slashes in front of it. Okay, and it just turns into regular text.
It turns it gray, and that means it's only for humans to read, and it actually won't ever be sent to the microcontroller. And it's a good way to like keep some code that you might want to use later, but you don't want it to execute right now. So like I want to show you the rest of these functions later, so I don't want to delete them. So but I don't want them on right now. So we can comment them out. And now our program effectively is only this one line, this call this color wipe function with my new color. And that's the only thing that will happen when we upload this this code.
Quick question. Keep it there too, because I'm doing everything you're doing. How did you learn all this? Did you self-teach yourself? That was Steph asked on YouTube. Shout out to Steph. I was thinking the same thing.
Yeah, I taught myself a lot of this. I taught myself a lot of code because I didn't go to engineering school, right? And as much as engineering school sounds great, I feel like the hands-on stuff is really where allowed my curiosity to like follow a self-learning journey where like I wasn't having to sit back and take a bunch of extra classes about theory and like learning about the different types of transistors and how they work like has come back to bite me in the past, but like I was like, oh, it's pink now. Like,
you got to the good stuff. You got to the good stuff quickly.
And it's because it's open source too that I'm able to, the internet, right? Is like this resource that even if I wasn't getting it at my college, I did get like the intro to the things I needed to learn, enough to learn like what to search. And then once you like have a few words about what to search, the whole world unlocks, right? So like that's what I think is important about like what we're doing today is that you're learning like the audience is learning like the vocabulary that you need to self-teach. Yeah. And because Arduino is open source and free, to use all the software and like thousands of people have made like thousands of libraries for different components to make them easier to use for beginners. It's like I just followed the publications that were already out there, and like I have a mind for photography and like explaining things to people. And so then I started putting together my own tutorials, and but yeah, largely I'm self-taught in the code. So like I'm not like a quote unquote real programmer.
You are a real programmer. I mean, I know what you're saying. You mean like traditional academically trained.
I've been shamed by real programmers. Oh, so like, man, you know, there's always, no matter how like much notoriety. Oh, you wanted me to check my audio. I'm so sorry. It should be the good one. Is it going in and out because I'm moving away from it?
I've been hearing it. It's been good. Nice necklace.
Okay, Steph, I just noticed this message from Steph from like 10 minutes ago already, so I'm sorry. So I got into it because I was curious and arty and creative and was able to find the free resources online. So I kind of like open source works like a little bit of a debt, like you owe a debt basically, like, right? Like you benefited from these free materials, so you are beholden to share alike, which is one of the like line items on a Creative Commons license is that like I'm sharing this freely for you to use and you can use it even commercially. There's a lot of like commercial products that started out as Arduino projects, but you have to like follow the rules of the license that say a lot of times you need to pay it forward.
Got it. And that's what you're doing. So we commented out everything. She's teaching us how to customize this. We commented out everything so that we can run one color wipe.
Yeah, one color, and my color looks like it's pink. So now you need to hit.
I changed mine to yours. I did the same thing you did. I copied off your paper, basically.
Yep, great. Now you hit the upload button. You might need to install a library or like a plugin.
I did that low key when we were doing it. So.
You did it? Okay, so you have the same. You see the same thing I do.
So your color is 255, 58, 120, and then the 50 on the. What does the 50 on the outside mean?
It's the timing of the animation. So if we make it shorter, I can go back to the color wipe function and show you. But if you make it short, it's a number of milliseconds between the LED flashes. Okay. So you know how it was like going at a certain speed. If I lower that number, it's gonna animate faster. Okay, cool. So I got it on 10, and then I just hit this. Now that it's connected to my Arduino Uno, I hit the check button, which I hit upload. Okay, right here, the arrow. Hit the upload button.
Boom. And now it's doing what you're doing. Console verifying on my end. Yours uploaded pretty fast. I guess it's because my first time, but it says it recognized my Uno, my device. And is that your pink right there? So your pink is there?
That's my pink.
Okay, mine is uploading. It's uploading. Boom, upload strength. And then look. Oh, look at me. What's up, y'all? You did it. Yay. How you like me now?
Hey. That's great. Okay, so now it's like, it's animating. but once it's on this color, like it's animating, but it's like drawing on top of itself. So we can't see the fun animation anymore because it's like it's pink and then it just stays pink. So I'm gonna add a new instance of this color wipe. I'm just copying line 57 and pasting it right below, and I'm gonna make it color wipe to 000, which is off.
So basically saying like go from pink, turn off. All right, so I just copied that same line of code. That's what you did. I'm keeping up with you. Becky. I may not have had an extra USB cord, but I'm keeping up with you right now.
I knew you'd be fine at this part. I knew you wouldn't have trouble.
You know what I mean? Okay, cool. All right. So 000 is like nothing, no color.
It's 0. It's off. Yeah, it's like, so the red LED off, the blue LED off, the green LED off.
Okay.
And now when you hit, you have to hit upload again. And what that does is it translates this code to machine code for the Arduino and puts it on the chip. So now if you were to disconnect this from your computer and plug it into like a USB battery pack or like a wall supply, it's running the program on the chip. It's not running it on the computer. So you're actually like putting this code in.
So now it's running like this?
Yeah. Now you got the animation. You can see it's animating.
Man, look, Becky just taught
pink.
Becky, you just taught me how to look at this.
Yeah, so cool, right? It like looks like the thing you got behind you.
Yes. And what I can do, so let me ask you this. So we just duplicated that line, went off. If I do another line with a different color and then do another line off, will it be like pink and then whatever my new color, like blue and
yeah, do you want to try that?
All right, let's try that.
That's what I was hoping that you would have some requests based on when you first got it. I knew then you would be like, oh, can we do this? And then I'll show you. Like, yeah. I just copied them both of those two lines.
It sounds like you taught this
and
before.
Then, sounds like I've taught this before. Yeah, just a few times.
Just a few times.
A few hundred times. So yeah, what color do you want to make?
So here's what I want to do really quick. I want to do like just whatever, 3 different colors. Can we just do that? You tell me we want to do something that's kind of greenish. Something greenish.
All right, let's do something greenish. So you can see that our pink is like heavy on the red and like light on the other two.
Yeah.
So we can like we can make like the red, make a green one that's greenish. I'm just keeping track in my comments because that's like proper coder etiquette.
Okay, let them know. So if somebody else sees your stuff, people.
Well, or just for yourself, for like your future self, if you don't remember. I can like say this one's reddish and this one's gonna be green, or the target is greenish. So I'm gonna make this like 255 is the highest. So I could max that one out, and then I could like add a little blue for funsies.
Y'all see
and
this?
Then
what else should I add to? Add a little blue for funsies to make it a little blue greenish or green.
So that's like a greenish color. Then let's do like an orange. So orange, if we do, we're talking about additive color here, not subtractive color. Subtractive color is paint. Additive color is light. So the main primary colors are R, G, and B. That's what we're working with here. Right. Not the primary colors you use on paper like yellow, red, and blue. Okay. So in order to make orange is actually green plus red. So if I do like all the way up on green and red.
So 255, 255. All right.
0. Yeah, that's gonna be orange. And likewise, if I want to make, or yellow rather.
Okay.
It's gonna be yellow. Let's see what happens. Let's do an experiment on the last one and see what happens if we put the green and the blue one all the way up and the red one all the way down.
Oh, we're doing 4 colors. Okay, cool.
Oh, I just.
No, it's cool. It's cool. Listen, the more the merrier. You know what I mean? We're with that. And plus,
so
I have you here with me.
What I'm saying is like, you can experiment with the colors and just like upload new versions. That's a fun thing to do. But you can also like go into your digital color picker on your computer or into Photoshop or whatever that has, or you can like, or there's like I'm sure there's ones on the web too, where you can like see a picture of a color gradient and then pick your color and have the RGB values. So if you have a color in mind, you can go research what the RGB values of that color are. And if you're like us and you were just playing around, you can also just play with the values and see what comes out, right? Like, I don't know what's going to happen. What happens when I combine green and blue? So that's like our yellow. Sorry, I thought it was going to be orange. It's not. It's yellow.
Oh, you already uploaded yours.
I did. Sorry.
Oh, you're used to this. You just like boom. Type.
I'm fast.
Type
I know.
Upload.
I'm
type
fast.
upload. Okay. Mine is uploading right now. Let's see what we got, y'all. I'm about to shut the overhead because they gotta feel the vibes over here. Switch it up. Talk to me. It's still verifying. All right, so there's my pink.
Yeah.
There's my pink. Next is my, what is it gonna be next? Green. Hey, y'all see that?
It's working, right? It's doing what you want.
It's doing. Now I got my teal, my greenish, bluish, whatever. And then next we should get the oranges one. Let's see if we got the orange one. Let's get the orange one.
Yellow.
Oh, it's more yellowish,
yellow.
but you know, it's close.
And if we want to make it orange, we can reduce the amount of green.
Okay.
So make it like so yeah, let's say okay,
blue.
we're targeting an orange. We didn't really succeed on our orange target yet, right?
No, we didn't. I'm digging,
let's see what happens if we do 255 like 150 0 and see if that makes it more orange, right? So I'm taking out some of the green.
Bring down some of the green.
I don't think of like color mixing this way is not super intuitive to me. But I went to art school anyway, so you can trust me.
You did, and I trust you because I didn't go to art school at all. Okay, cool.
I learned my color theory. I don't have to be good at
it. All right, let's see. Let me see. And by the way, in a second, I'm gonna ask you again about all the projects you have online, the things you've been doing online. But let me see if my everything works right. It's uploading now. Let's see. Start with pink. Chat. We got the pink. And then we got the next we're doing with the tealish, right? The greenish. There we go. We got the green.
Mm-hmm.
Becky, you're a good teacher. All I know. Come on, here we go. Then we're gonna try to get a little more orange on this one.
It's fun, isn't it? Like
it is.
To make the color that you made. It's very satisfying.
A little more orange.
Love seeing.
Okay, we should have probably brought it down a little bit more, huh?
Yeah. We're also dealing with the fact that our strip is at a lower brightness, so all of these values are being scaled to that global brightness that we set in the beginning.
Got you.
So like, color mixing, it's not a perfect science. There are some things having to do with the human eye that we're not accounting for.
I'm gonna probably make some jewelry out of this or something at some point and just kind of stun on them.
Me too. We're wearing it. I'm a wearables expert. We're wearing our LEDs as a necklace.
Yes.
I just wanted to show you. I think it's fun with a lot, and I just had these strips hanging around.
This is incredible.
A lot of other form factors that these LEDs can come in, like little jewels or sticks, and you can cut this strip to any length. So I just wanted to show that like it's easy to expand it to a lot, but you can also do a lot with just like 8 of these LEDs instead of 300.
Indeed. And then make wearable tech. Now, Becky, go ahead and remind us again what kind of stuff you got out there that people, because you're a great teacher. Isn't she a great teacher, chat? Y'all let her know. Affirm her in the chat. She's a great teacher, but let everybody know what else you got going on as we support some of your
I think I'm the better asynchronous teacher than live teacher. So like you just got live, Becky, but there's like a lot of like edited versions of me that I think are much more succinct.
Yeah.
I do have a YouTube channel. You can just search my name, Becky Stern, on YouTube, or you can link me in the chat, or click on my name in the chat. And that's like mainly where I'm publishing videos, but on my website, beckystern.com, you can find like everything I've ever done, including links to my Arduino class and my knitting class if you want to, learn something completely different. Yeah. I also do a lot of fiber arts and crafts. And my main thing is like combining this tech with like other design to make like a product that like solves a problem for you or expresses some creativity, like a Halloween costume.
Mm-hmm.
And then always share like I'm not just making it to be sensationalist and get your clicks. I'm also like showing you the tools that I'm using and linking to everything so that if you get inspired by an element of one of my projects, that you can follow that thread and sort of teach yourself what I did. And like I leave the breadcrumb trail, as is my open source duty.
Yes, and now I have the duty because you sent me all this great gear that I know how to program now. So I've taken my first step and passed it on by having the great Becky Stern on the show. Y'all show some love. We already got people. What a great teacher. Synchronous Becky. A clockwork
synchronous, yeah, synchronous versus asynchronous. Yeah. I think would be a cool project for you, Dr. Nee, is to you could take this strip that you have, try to match that pink you have on the bars behind you, and like put it behind your bookcase, and your bookcase could have like an outer glow. You put the LEDs like kind of facing the wall, taped to the back of the bookcase, and you'll get this like bookcase outer glow, and you can have your setup, your whole LED setup with your background.
I think I might do that. Hey, that's for the record, y'all. Yeah, that idea came from Becky. So when y'all see me stunting my setup back here, looks even better. It's because thanks to Becky. Again, keep the thanks coming. I'm going to share everybody really quick, just a reminder of what we have coming up just tomorrow, because we are almost done with this week. Tomorrow, we've obviously had coding. This week was a heavy coding week, and I'm glad. I hope we sparked some interest for you all. But tomorrow we're going to get back on Minecraft. Dr. Pamela Gay is going to walk us through and play a little bit with your boy on Minecraft, because we played on Monday. and I did all right, but I could use a little more help. I get confidence, Becky. Shout out to Becky again. I get confidence when I have gurus like yourself on the stream with me. So thank you for coming on today. Tomorrow we're gonna have Dr. Pamela Gay. Yesterday we had Meta Dev Girl. And then early next week, again, just go ahead and let you all know, just like we did 4 p.m. Eastern this week, we're gonna do the same thing next week. So mark your calendars for that. Becky, anything you want to say before we say goodbye? Bring you back on.
I had such a fun time. This was great. Thanks for hanging out and having me on.
Thanks for hanging out. Yeah, awesome. Well, y'all, thank you all for hanging out. Much love. Go ahead and hit follow if this is your first time on our stream on Twitch. Of course, you can hit subscribe on YouTube. And if you're on YouTube, come over to Twitch. As a matter of fact, tomorrow we're going to be there exclusively. And we want to continue to get closer and closer to our 700 followers there on NOVA Building Stuff, at NOVA Building Stuff. Thank y'all so much for hanging out with us today. Yes, we had a little bit of a technical fruit basket upset, but guess what? That's what engineering is all about. And now that I know how to code, I'm about to go to a whole new level. But until next time, you all take care. And no matter how many issues you have, even if you too only have one USB cord at the time, whatever you do, just keep building. All right? Peace.